to deal with some problems. The first problem is if y is equal to a into 1 minus cos t and x is equal to a into t plus sin t, find d square y by dx square. So first of all, here we have to find dy by dx and dy by dx, and in the next step we have to find d square y by dx square. So first of all, write down what is y and what is x, and we have seen that the value of y and x are in terms of t, so we have to differentiate in terms of t and then we will divide it. So y is equal to a into 1 minus cos t. So first of all, we are differentiating y, so dy by dt is equal to, since a is a constant, we write a itself, and we are differentiating 1 minus cos t. So in order to differentiate 1 minus cos t, we have to differentiate first of all 1 and then we have to differentiate cos t. We have to do it separately. So dy by dt of 1 is equal to 0, since 1 is a constant. 1 is a constant. And d by dt of cos t is equal to minus sin t. So we are writing here a into 0 minus sin t. So we will get a into 0 plus sin t, which is equal to a sin t. It's equal to a sin t. So we get the value of dy by dt. Next, to obtain the value of dx by dt, we write what is x. X is equal to a into t plus sin t. So we can differentiate x. Dx by dt is equal to, since a is a constant, we write a itself, and the differentiation of t in terms of t, dt by dt is equal to 1. So 1 plus sin t. The differentiation of sin t is cos t. So plus cos t here. So this is the differentiation of x. So we get the differentiation of x also. Now we are going to divide it. So we are going to divide dy by dt divided by dx by dt. So it will be dy by dx, because dt cancels, and it will be equal to, since dy by dt is equal to a sin t, we are writing here a sin t, and dx by dt is equal to 1 plus cos t. So we are writing here, a into 1 plus cos t. So we are writing here a into 1 plus cos t, and a cancels, and we get sin t by 1 plus cos t. Already got what is dy by dx, that is sin t by 1 plus cos t. So we have to simplify it. In order to simplify it, we have to apply some formulas. First of all, we can look what is that formula. So we already know this formula. Sin 2 theta is equal to 2 sin theta cos theta. Here, when it is 2 theta, we get in the RHS the half of 2 theta. So here we are getting the half of 2 theta, that is theta. So when we are trying it for sin theta, we get 2 sin, what is the half of theta? Theta by 2 into cos theta by 2. So we are applying it for sin t. So it will be equal to 2 sin t by 2 cos t by 2. So this is the first equation we are going to substitute for simplifying dy by dx. Next one, that cos 2 theta is equal to 2 cos square theta minus 1. So cos 2 theta plus 1 is equal to 2 cos square theta. So when we try it for cos theta plus 1, we will get 2 cos square theta by 2. Here 2 theta will be theta when it comes to the RHS. So half of 2 theta is theta. Here when we are taking theta, it will become theta by 2 in the RHS. So we get this formula. So we can substitute it for cos theta plus 1 in the result of dy by dx. So here dy by dx is equal to sin t by 1 plus cos t. So instead of it we substitute 2 sin t by 2 cos t by 2 divided by 1 plus cos t will be equal to 2 cos square t by 2. Next 2 cancels and 1 of the cos t by 2 from here cancels and 1 from here cancels, and we will get sin t by 2 divided by cos t by 2, which will be equal to tan t by 2. Next we are going to do d square y by dx square, which is equal to d by dx of dy by dx. So it is equal to d by dx of tan t by 2, which is equal to the differentiation of tan t by 2 is sec square t by 2, and here the denominator is dx, that is we are differentiating in terms of x, but here it is tan t by 2, so we have to differentiate this t by 2 again into d by dt dx of d by dx of t by 2, which is equal to sec square t by 2 into, for d by dx of t by 2 we take half is a half outside, since half is a constant, and we will do the differentiation of t in terms of x. So we already know that dx by dt is a into 1 plus cos t. We have already differentiated x in terms of t at first, and we have got a into 1 plus cos t. So dx by dt is a into 1 plus cos t. So dt by dx is half into 1 by a into 1 plus cos t. Okay. So we are substituting it here. Sec square t by 2 into half into 1 by a into 1 plus cos t. Okay. We have already seen that a plus cos t is 2 cos square t by 2. So we can substitute it there. So sec square t by 2 divided by 2a into 2 cos square t by 2. We know that 1 by cos is equal to sec. 1 by cos is equal, so we substitute 2a into 2 cos square t by 2. We substitute 2 cos square t by 2 instead of 1 plus cos t, and we know that 1 by cos is equal to sec, so we write it as sec square t by 2 into sec square t by 2 divided by 2 into 2 4a. Okay, so we will get sec raised to 4 t by 2 divided by 4a. This is equal to 1 by 4a sec raised to 4 t by 2, which is the answer. Next question is, if y is equal to a cos nx plus b sin nx, prove that d square y by dx square plus n square y is equal to 0. So first of all, write down what is y. Y is equal to a cos nx plus b sin nx, and we have to differentiate y first, and we have to differentiate it again. means here we have already given, we have to prove d square y by dx square plus n square y is equal to 0. Here we have to find d square y by dx square first, so we will normally reach to the answer. So first of all, write down dy by dx is equal to, we have to differentiate y separately because it is an addition. First of all, we have to differentiate a cos nx and then b sin nx. Because it is addition, we are differentiating a cos nx and b sin nx separately. First of all, since a is a constant, we write here a itself, and the differentiation of cos nx is minus, here it is nx. In the question, yes, it is nx. It is nx here. So when we are differentiating a cos nx, we will get, since a is a constant, we write here a itself, and the differentiation of cos nx is minus sin nx. Here the term is nx. It is sin nx. So we are differentiating it in terms of x, and here is term sin nx is there, so we have to differentiate that nx once again, so we will get n itself. I'll show you. D by dx of nx will be equal to, we will take n outside since n is a constant, d into d by dx of x, which will be equal to d n into 1 is equal to n. That's how we get n here, and plus the b is a constant, we write b itself, and the differentiation of sin nx is cos nx, and we differentiate nx once more and we will get n, and we can write it as d by dx is equal to minus n a sin nx plus nb cos nx. Okay, now we have to differentiate it once more, so we write it as d square y by dx square will be equal to d by dx of minus na sin nx plus nb cos nx. Differentiating this, we will get, since n is a constant, we write na itself, and the differentiation of sin nx is cos nx, and here there is nx, so we are differentiating nx again into, so we will get n plus nb is a constant, and the differentiation of cos nx is minus sin nx into n. Since there is nx here, we are differentiating it again, so it will be equal to minus na cos nx, minus n square a, there is one more n, minus n square a cos nx plus n square b into minus sin nx. So we will get minus n square a cos nx minus n square b sin nx. Here it is sin nx, okay, which will be equal to, we will take minus n square outside, so n square into a cos nx plus b sin nx. This will be equal to y sin nx. Okay, here it is sin nx, so it will be equal to y, which we have already given, which is already given in the question. In the question we have given that y is equal to a cos nx plus b sin nx, so it is y itself, so it is equal to minus n square y. So we get d square y by dx square is equal to minus n square y, and we are transposing this minus n square y to left hand side, so we will get d square y by dx square plus n square y is equal to 0. Okay, so this is the thing we are given to prove. So we have got the answer.